Imagine you stop eating after dinner and decide to do a full 24-hour fast. No snacks, no late-night treats, just water, maybe some coffee or tea. On the outside, nothing dramatic seems to happen in the first hours. You go to sleep, you wake up, you go about your day. But inside your gut, it is anything but quiet. Your intestinal tract is still moving, secreting, cleaning, and your microbes are reacting to the sudden silence of food. Your gut is like a busy city that never truly shuts down. Even when no new food is coming in, there is mucus, old cells, digestive juices, and compounds released by your own body. Bacteria do not just sit and wait politely for your next meal, they adapt. Some slow down, some change what they eat, and some even get a temporary advantage from the food break you are giving them. And here's where it gets really interesting. A simple 24-hour fast is short on the human timeline, but long enough for your gut bacteria to feel the difference. Hormones shift, the way your intestines move changes, and the chemical messages your microbes send to your brain start to adjust. By the end of this video, you will understand whether that pause from eating is helping your gut community, stressing it, or doing a bit of both. Before we track what happens during a fast, we need to know who lives inside you. Your gut microbiome is a huge community of bacteria, viruses, fungi, and other microbes that live mostly in your large intestine. There are more of them than human cells in your body, and together they behave almost like another organ, helping you digest food, producing vitamins, and training your immune system. Not all of these tiny tenants act the same way. Some prefer fiber from vegetables, fruits, and whole grains. Others thrive on fat or protein leftovers. Some species are linked with health benefits, like making short-chain fatty acids that nourish your gut lining, while others are associated with inflammation and disease when they become too dominant. What you eat each day works like a constant election, deciding which groups get more power. Because they respond so quickly to food, your microbes are extremely sensitive to any change in your eating pattern. A few days of ultra-processed food can already shift the balance, while a diet rich in fiber and variety tends to support a more diverse, resilient community. A single 24-hour fast is not going to erase years of habits, but it is enough to trigger a noticeable change in what some of these microbes are doing, and that is what we're about to break down, step by step, across the first day. The clock of your fast starts with your last real meal. In roughly the first 4 to 6 hours, your body's still using energy from that meal. Blood sugar rises and then falls, insulin goes up and then comes down, and your liver is releasing stored glucose to keep things stable. To your gut bacteria, this is still a fairly normal post-meal period. There are undigested carbohydrates, fibers, and other nutrients slowly moving along your intestine. During these first hours, many microbes are busy fermenting the leftovers from your meal. They break down fibers that you cannot digest into small molecules like acetate, propionate, and butyrate. These short-chain fatty acids help feed your colon cells, support the mucus layer that protects your gut wall, and even influence your immune responses. So early in the fast, the bacterial workday is still running on last night's dinner. You may not feel hungry yet, especially if your last meal was substantial, but the system is already preparing for a change. As glucose becomes less available and insulin falls, your body starts to signal a shift away from constant incoming fuel. Your microbes sense this indirectly through different bile acids, hormones, and changes in how fast things move through your gut. The real test for them begins once the easy carbohydrates run out and no new food arrives. Somewhere between hours 6 and 12, your body leans more heavily on stored energy. Glycogen, the stored form of glucose in your liver, is being used up, and your metabolism slowly starts to rely more on fat. You are not in deep ketosis yet, but the direction is clear: less sugar, more fat burning. Inside your gut, the flow of fresh nutrients from your last meal is now very low, and this forces your microbes to change strategies. With less digestible food arriving from above, many bacteria shift to fermenting what is always present, your intestinal mucus and the complex carbohydrates that line your gut. Certain microbes are specialized in using this mucus as a fuel. That might sound alarming, but under normal conditions, this process is part of a healthy cycle because your body constantly renews and rebuilds that mucus layer. The key question is whether the balance between using and rebuilding stays under control. You might begin to notice subtle changes. Your stomach feels emptier, bowel sounds may get louder, and you could experience either a calmer gut or some mild discomfort, depending on how used you are to fasting. Motility in your intestines may slow down a little, giving bacteria more time with the remaining material in your colon. At this stage, they are essentially stretching yesterday's meal as far as possible while adapting to the quieter environment. Once you cross roughly 12 hours without eating, your body is much more reliant on fat stores and is producing more ketone bodies. Many people begin to feel a different kind of hunger here, waves that come and go, sometimes mixed with surprising clarity or focus. Meanwhile, your gut bacteria are facing a clear fact: no new food is coming anytime soon. The spotlight turns even more to mucus, sloughed-off cells, and the compounds your own body releases into the gut. This is where a common fear appears. If bacteria start using mucus as fuel, are they basically eating your gut barrier and damaging you? In a short fast of around 24 hours, the evidence suggests a more nuanced picture. Yes, some mucus-feeding bacteria become more active, but your intestinal cells also keep producing new mucus, and certain beneficial microbes may increase their production of short-chain fatty acids that actually support the integrity of the gut lining. In other words, it is more of a controlled adjustment than a horror scene. What does seem to happen is a temporary reshuffling of who is most active and what kinds of molecules they produce. Some studies suggest that short fasts can reduce pro-inflammatory signals and give the gut a small rest from constant digestion, while others show that the effects depend a lot on your usual diet and health status. And now I am curious about you. Would you personally try a 24-hour fast, or have you already done it? Tell me in the comments what your experience was with going a full day without food, and if you noticed anything in your digestion or mood. When people say good and bad bacteria, they are really talking about how those microbes behave inside a specific context. Some microbes are linked with benefits, like making short-chain fatty acids, keeping the mucus layer healthy, and helping to control inflammation. Others are more opportunistic and tend to bloom when there is a lot of sugar, ultra-processed food, or chronic stress in the body. A short fast pushes this whole ecosystem into a slightly different game. During a 24-hour fast, bacteria that are flexible and able to feed on mucus or resistant fibers have a natural edge. Many beneficial species fall into this category and keep working quietly, making molecules that nourish your colon cells even when no new food comes in. At the same time, some sugar-loving bacteria see their favorite buffet disappear. For them, this kind of pause is not such a great deal. This does not mean a single fast turns your microbiome into a perfect, good-only community. Think of it more as a small reset of the daily rhythm. You remove constant snacking and late-night eating for one cycle, and that can slightly favor microbes that handle scarcity better and do not depend only on quick sugars. The real power still comes from what you usually eat on non-fasting days, but the fast can tilt the balance in an interesting, temporary way. You have probably heard people talking about leaky gut, as if your intestines suddenly become full of holes. In reality, your gut barrier is a living, dynamic wall made of cells, mucus, and tight connections that open and close in a controlled way. This barrier decides what gets absorbed into your bloodstream and what stays out. Many things can affect it: chronic stress, lack of sleep, infections, certain medications, and of course, diet. A short fast of around 24 hours seems to change the chemical environment around that barrier. With no new meals coming in, there is no constant wave of fat and sugar hitting the system. Some studies show that fasting periods can reduce circulating inflammatory markers and might lower the passage of certain bacterial fragments from the gut into the blood in the short term. For some people, that looks like a brief break from the digestive load of the day. On the other hand, if someone is already very undernourished, has a very fragile gut, or is dealing with serious illness, skipping food for a full day could be more stress than relief. The barrier needs energy and nutrients to maintain itself. So for a generally healthy person, one controlled fast may nudge inflammation slightly downward for a moment. For a weakened system, that same challenge might not be a good idea. This is why context always matters more than any simple rule. Hunger during a fast does not come only from your stomach being empty. It is a cocktail of hormones, nerve signals, and chemical messages, many of which are influenced by your gut microbes. As the hours pass with no food, hormones like ghrelin rise and fall in waves, and your microbiome is still producing small molecules that can interact with the nervous system. That is why one person feels calm and focused while another feels irritable and foggy. Some bacteria make compounds that act a bit like messengers for your brain, influencing mood and appetite. They can interact with the vagus nerve, a direct communication line between gut and brain, and with the immune system, which also affects how you feel mentally. During a fast, this chemical conversation changes because the type of fuel available to microbes changes. Less sugar, more use of internal resources, different levels of short-chain fatty acids and ketones all shift the tone of that talk.
You might notice that cravings become more specific as the day goes on. First, you simply want food. Later, you may crave very sweet or very salty things. Part of that comes from your brain chasing fast energy, and part may reflect which microbial groups are more active and what they are used to receiving from your usual diet. If you often feed them sugar, intense cravings might be stronger. If your routine diet is rich in fiber and whole foods, the ride through a fast can feel smoother. Even though a single 24-hour fast can be safe for many healthy adults, it is not for everyone. People with diabetes who use insulin or certain medications can have dangerous drops in blood sugar if they stop eating without medical guidance. The same is true for those with serious heart disease, chronic conditions under tight treatment, or who are taking drugs that must be taken with food to avoid side effects. For these groups, a long fast should not be a casual experiment. There are also life phases and situations where fasting is generally not recommended. Children and teenagers are still growing and need a regular intake of energy and nutrients. Pregnant and breastfeeding women are supporting another life and often have higher nutritional demands. People with a history of eating disorders, very low body weight, or strong anxiety around food can find that strict fasting triggers unhealthy behaviors or thoughts. In these cases, protecting mental and physical stability comes first. So if you saw the title of this video and thought, "Should I try this tomorrow?" An honest answer is, talk to a qualified health professional first, especially if you fit into any of these groups. Science can explain mechanisms and trends, but it cannot replace individual medical advice. Your gut bacteria are important, but so is your heart, your brain, your hormone balance, and your relationship with food. All of that needs to be part of the decision. When you put all the pieces together, a 24-hour fast looks less like magic and more like a gentle nudge to a very complex system. It seems to temporarily change which microbes are more active, how much short-chain fatty acids they produce, and how your gut barrier and inflammation behave for a brief period. In generally healthy people, repeated short fasts, done in a sensible way, may contribute to better metabolic flexibility and a slightly more resilient microbiome over time.
However, your gut bacteria do not judge you by that one fasting day alone. They respond far more strongly to the pattern of what you eat most of the time. Diets rich in varied fibers, colorful plants, fermented foods, and minimal ultra-processed products build the type of diversity that predicts long-term gut health. If someone fasts once a week but lives on fast food the rest of the time, microbes will listen much more to the daily junk than to the occasional pause. So, should you repeat a 24-hour fast? If you are healthy, cleared by a professional, and you feel good during and after it, it can be one tool among many to support your gut and metabolism. Just remember that the real foundation is still everyday habits. Use fasting as a thoughtful practice, not as a punishment or a quick fix. And if this explanation helped you understand what actually happens inside your gut, consider giving this video a like, subscribing to the channel, and sharing it with someone who is always curious about nutrition and health. This video is for education only and isn't medical advice. If you have a medical condition or take medication, talk to a qualified professional before fasting.